So, what's up, guys? Once again, we are back with another interview, and today we are going to take mock interview of DSA. So, आप भले ही कितना ही वेब डेवलपमेंट, ब्लॉकचेन, वेब थ्री, दुनिया भर का कुछ भी कर लो, लेकिन अल्टीमेटली जॉब तो डीएसए ही दिलाएगा।
तो आता है तुम्हें डीएसए?
हाँ, आता है।
तो ये बताओ, सॉर्टिंग की सबसे अच्छी एल्गोरिथम कौन सी है?
यही है, बबल सॉर्ट।
सीरियसली तुम इंटरव्यू में ये बोलने वाले हो?
यार,
टाइम कॉम्प्लेक्सिटी पता है इसकी कितनी होती है?
वही होती ऑर्डर ऑफ एन स्क्वायर।
तो इसे ऑप्टिमाइज कौन करेगा?
ये है ना हमारा इंटरव्यूअर, ये किस लिए है?
चलिए छोड़िए इसे। आज हम देखते हैं हमारे कॉन्टेस्टेंट को कितना अच्छा डीएसए आता है और वो किस कॉम्प्लेक्सिटी में परफॉर्म करता है। लेट्स सी।
यो
Hello, Pranshul.
Hello, sir.
So, how are you feeling today?
I'm feeling very fine and I'm up for the interview.
So, let us begin with your
Okay.
introduction first. Can you introduce yourself?
Hello, my name is Pranshul Rajvet and I am from Khandwa, Madhya Pradesh. Currently, I'm studying computer science and engineering from Lakshmi Narayan College of Technology. My aim is to become a software developer. My technical skills are that I'm a full stack web developer and I'm good in problem solving in DSA. My strengths are that I can work with team and I'm an adaptive learner. I am an active listener. My weaknesses can be that I procrastinate a lot and I'm fixing it by making daily schedule. And sometimes I try to become perfect in things that I miss any opportunities, and I'm fixing it by applying to as many opportunities as I can. And that's a little about me.
Okay, that's great. Can you share why did you choose DSA and how it is going?
Because the DSA we tackles new problems on the daily basis, and it aligns with my understanding of the core subjects of computer science, and it also challenges me to solve new problems, and it also equips me with the mind to tackle the industry level problems.
Okay, so let's begin with your interview of DSA. So, first
Okay.
question for you would be, what do you know about red black tree?
Red black tree is a binary search tree, and it is a self-balancing binary search tree. So it balances itself. But why do we need to balance it? Because what happens is, in a normal binary search tree, it got skewed. What happens is, when we insert the sorted array or sorted elements, it aligns or is skewed in one direction. For example, if we insert 1, 2, 3, 4, it will skew in one direction, only in the right direction. So what happens is, in the time of searching, when we want to search something, the complexity becomes O of n instead of O of log n. But we need to maintain the complexity of O of log n. And to maintain it, we have to balance it again and again. And to tackle this thing, we created this self-balancing tree, which is red-black tree. In red-black tree, every node has a overhead of a color. It can be red or it can be black. So it helps in balancing itself.
Okay, and how can we optimize it? Any idea?
A red-black tree.
Yes.
A red-black tree provides the time complexity of O of log n, which is logarithmic time complexity, and it is already optimized, I think.
Okay.
It is better than AVL tree, because what happens in AVL tree is that there is so much of rotation in this. So whenever we want to delete something or insert something in AVL tree, what happens in AVL tree, whenever we want to delete something or insert something, it rotates itself a lot, which increases its complexity. But in the case of red-black tree, this rotations, the count of rotations get decreased. So it is optimized than both of its previous version, which is AVL tree and the binary search tree.
Okay. Can you share some of the points that we should follow during applying the red black tree?
Okay, like the characteristics of the red-black tree.
Yes.
The first and most important characteristic of the red-black tree, that each node should be colored. Either it can be red or it can be black. We don't need to apply the color. We can use any kind of variable. For example, a Boolean variable, 0 or 1, in which 0 represents red and 1 represents black. And another thing is the root. The root of the tree must be black. And there cannot be two consecutive nodes of red color. Like in the red color cannot maintain a child and parent relationship. Only the black node, the black colored node, can follow the child-parent relationship. The new node which we enter should be red, should always be red. And the most important property of the red-black tree is that the black length, the black node in both the parts of a node should be equal.
Okay.
And the leaf node, for example, there is a leaf node which do not have any children. So we will assume that both of its children are black. So these are some properties and characteristics of red black tree.
Okay. So Pransul, can you let me know what do you know about Dijkstra's algorithm?
Yes, sir. Dijkstra algorithm. It is an optimized. It is a greedy based algorithm. It is find the shortest path from one source to all the vertices of a graph. For example, we have a graph in which we want to find the shortest path to each of other vertices. So we can use Dijkstra's algorithm. It is a greedy algorithm. So it finds the optimized version, find the optimum solution, local optimum solution, and creates a global optimum solution. What happens is here we use two kind of data structure. It can be priority queue, min heap, or a set to take the shortest, or what we can say is the smallest weighted edge to get to a source.
So Pransul, do you know about A-star algorithm? And is there any difference between A-star and Dijkstra's?
Yes, sir. Actually, I know about A-star algorithm. It is also optimized algorithm to find the shortest path between the source and a node. But in A-star it is faster than Dijkstra's algorithm, but it may not find the best solution. It has more better time complexity than Dijkstra's algorithm, and it finds the shortest path between two nodes, not from one node to every node. It finds the shortest path between only between two nodes, and it finds it in more speed. But the path it finds, the shortest path which it finds, may not be the right answer.
Okay. You are saying that A-star is faster than Dijkstra's. Can you tell me about the time complexities of both?
Yes, in the case of Dijkstra's algorithm, the time complexity of the Dijkstra's algorithm is order of log v. Log v, because we use priority queue or a set. So log v multiplied by v plus e. So v plus e is for vertices and edges, because we traverse the whole edges and vertices. So it is order of log v into v plus e.
And what about the A-star time complexity?
Actually, I am not sure about the correct and exact time complexity of A star.
Okay. So Pransul, A-star is a preferred when a heuristic is available for estimating the shortest path. So this ultimately reduces the number of explored nodes and it reduces the time complexity ultimately. So you
Oh,
may go further with the what is A-star algorithm, and we must move forward with
okay.
the new question. So can you compare between the top-down and bottom-up approaches in dynamic programming?
Okay. So dynamic programming, it is an optimized it is a optimized technique to find a solution. We use dynamic programming when we have the overlapping sub solutions. The solutions we are trying to find, we divide the solution into sub problems. Like we have a problem and we create a tree of sub problems. But what happens in the case of sub problem, we have to calculate the same sub problem again and again. So to optimize this thing, we can use dynamic programming. But what happens in the case of dynamic programming, we can use two kinds of methods to do this. One is the memoization and one is the tabulation. Memoization, also known as top-down approach, and the tabulation, which is also known as bottoms-up approach. So what happens in top-down approach, we start from the top. We start from the starting of the point, and then we get deeper into the sub-problem tree, and then we find the solution and then come back again. In case of implementation, the top-down approach, we uses recursion. We uses recursion and memoization array to store the solution of a sub-problem. So we store the solution of a sub-problem in an array, which we can call it a DP array and the memoization array. So we store the solution of the sub-problem, and whenever we encounter the same sub-problem again in the recursion, we directly uses this solution which we find earlier. So this optimizes the time complexity from the exponential time complexity to the quadratic time complexity or polynomial time complexity. So it helps to reduce time complexity and make the solution optimized. But what happens in the case of bottoms-up approach, which is also known as tabulation approach, we create this the DP array, which we call a DP array or a tabular array. So we create this tabular array from the beginning of the solution. We have to find the knapsack solution. So we directly go towards the 0th weight, and then we start building the solution from the bottom, from the 0th index to the nth index. In case of top-down approach, we were going from nth index to the 0th index. In the bottoms-up approach, we will go from 0th index to the nth index. We build the array from the initial stage. In the case of implementation, the bottom-up approach, we use the iteration method. We don't have overhead of recursion in this thing. In the bottom-up approach, we can directly use the iteration method. We can use the loops, for loop or while loop, to build this DP array and find the most optimum solution.
Okay. And what can be the best case and the worst case of the time complexity?
in the scenario of top-down approach, the memoization approach, the worst case time complexity can go in exponential, because there can be many different paths which needs to be followed to find the answer, and the chances of getting the solution of sub problem may be high. So the time complexity might be exponential, but it depends from problem to problem. Like in knapsack problem, we can do this with in O of n square, and if we don't use the memoization, it can be O of 2 to the power n. But in case of tabulation, in the bottoms up approach, we are sure that the time complexity will only be in polynomial because we are using loops.
Okay.
So in case of time complexity, bottom up approach is better.
Okay. Pransul, can you share your screen?
Okay, sir. So is my screen visible?
Yes, it is. And can you open a VS Code?
Okay, sir.
So,
Is
Pransul,
it
as we
visible?
have discussed about top and bottom top approach of DP, can you show an example and like take an example of Fibonacci series and how we can perform both of these?
Okay, sir. So let's take the example of Fibonacci series. First, we create an array. So, so suppose we need to find the Fibonacci for the nth index, which can be 5 or 6. Let's take a variable n, and we need to find the nth Fibonacci number. So we will use the Fibonacci function for this. Let's build this Fibonacci function. So in case when we hit the 0 or 1, we have to return it. So Fibonacci number is the sum of its two previous elements. So with the help of recursion, we can easily solve this problem. And so we can see it is returning the answer. So how can we apply the dynamic programming here? Here we can use the dynamic programming array. So let's take this array. This array will help us to memorize the answer. It will help us to maintain the solution of a subproblem. So here we will check if we already know the solution of this subproblem. And if we know the solution of the subproblem, we will directly return it instead of solving it again. And when we have to solve the subproblem, we will store the solution. So let's run it again. As you can see that it is giving us the answer again. So it reduces the time complexity from exponential to the polynomial.
Okay.
But this is the memoization approach, the top-down approach. We can use a tabulation-based approach. So what we can do is, if we have to find the answer of the nth position of the Fibonacci sequence, we can build this from the start. So let's take two elements. One is 0 and one is 1, and we will start from so the current element is the sum of its previous two elements. And once we find the current element, we will also update the previous elements. So as you can see that this is the iterative solution. It is the tabulation solution, which is the bottom up approach. Here we are not using the DP array. Instead, we can simply use the two variables, previous one and previous two.
Okay. Pranshul, can you discuss about the space complexity of both of the methods?
Okay, sir. So the space complexity of both methods is O of n, because in both the methods we are using the dynamic programming array, which is this array. And even in this solution, bottoms up approach, instead of using these two variables, we can simply use the dynamic programming array again. And so the time complexity of this solution will again become the space complexity of this solution will again become O of n.
Okay. So you are saying that we can use any of them, and
Yes.
it doesn't matter in terms of time or space.
No, sir. In time complexity, bottoms up approach is faster.
Okay. And what will be the complexity? Time complexity?
The complexity will be same, but this will use the iteration method. And according to a question, according to constraints of the question, the time complexity of top-down approach may go exponential. So, in case of bottom approach, in case of bottom-up approach, we reduce the chances of the time complexity getting exponential.
Okay. Okay, Pranshul. Do you know about bucket sort?
Yes, sir. So, bucket sort algorithm is an algorithm to sort an array in ascending or descending order. There are two kinds of bucket sort algorithms. One is radix sort and one is count sort. What happens in bucket sort algorithms that these are non-comparison based algorithms. We don't compare the elements with each other. The previous algorithms like insertion sort, bubble sort, or even merge sort, we have to compare the elements with each other to find the minimum or maximum element. But what happens in bucket sort that we create a frequency array or a count array which stores the frequency of the elements, and these elements on the basis of their frequency gets sorted accordingly. So this bucket sort algorithm, the main point, the main selling point of the bucket sort algorithms is their time complexity. The time complexity is very less compared to other algorithms. The time complexity is O of n. N is the size of the input. So the time complexity is very less. But the main problem is this works only when the range is very less. For example, the smallest element is 5 and the biggest element is 100. So the range is very less. So we can use it. But for example, the smallest element is 5 and the greatest element is 1 crore. So this will create problem because we have to create the frequency array of this much size, and it will become more redundant and more problematic. So this works well when the range is small. So the time complexity is O of n, and the space complexity is O of n plus k, where k is the range.
So, Pranshul, you are slightly correct, but not completely. Because what happens in the bucket sort, it is only used to sort the floating point numbers between the range 0 to 1. Okay? And based on the first decimal place number, we use a bucket to sort these numbers according to the first decimal place. Like if we have 0.7, the first decimal place would be 7, and we create a bucket where at the index 7, the value gets stored. And based on these buckets, we sort the whole bucket, means we sort all the numbers, and the worst case of this would be if we have two floating numbers like 0.71 and 0.75. So first decimal place of both numbers are
0.77.
Yes, the first place of both of the numbers would be 7. So these would lead to the worst case, and we have to apply one more loop to sort these based on this particular condition when these both floating numbers have same first decimal place. So this might be a worst case of this, and you may go through the bucket sort later on, and the time complexity.
Thank you for correcting this.
Yes, and the time complexity of this bucket sort is also not the one you told us. It is the big O of n plus k, where n is the size of the array and k is the size of the bucket.
Okay.
So yes, and okay, Pranshul, let's move on to next question. Do you know what convex hull problem?
Actually, I read it somewhere. It is divide and conquer based problem. We try to find a 2D set, a kind of a 2D structure, because we have given so many points on a 2D map, a 2D plane. So we need to bind or to collect all these points inside that 2D structure. So we have to create the minimum area 2D structure to contain all the points. To solve this, we use the convex hull approach or an algorithm. It's a divide and conquer based algorithm. So this is all I know about the convex problem.
Okay, Pransul, you are almost correct. As you said, it is based on the divide and conquer algorithm, and it is used to cover all the points on a plane into an polygon. And for this, we can use the convex L problem. And do you know about the complexity of this problem?
No, actually, I don't know about the complexity.
Okay. The complexity, time complexity of this would be big of n log n,
Okay.
and for it, it is for Graham's scan. And we also have a divide and conquer algorithm, as you said. The complexity for that would be big of n log n, that is same as the Graham's scan.
Okay,
And
sir.
and the space complexity. Okay, so space complexity for this is big of n. Also, you can go through this problem, convex L problem later on.
Of course, of course.
Okay, and let's move on to the next problem. Pransul, you may stop presenting. Okay, Pransul, describe the trade-offs between time complexity and space complexity.
So the trade-off between time complexity and space complexity, this can be a very old and very highly debating topic that on which thing we should focus more, time or space, because both time and space are the biggest resources that we have in computer science. So what we can do is on solving a problem or on building a logic, we have to think about the time and the space. So we can use the time complexity and space complexity trade-off. Even if we take the example of dynamic programming, so we are reducing the time complexity from exponential to polynomial, but instead we have to use a dynamic programming array, which can be very large and it can be very complex based on the different data structures on which we are applying the dynamic programming approach. So, so it is increasing our space complexity, but at the same time, it is decreasing the time complexity from exponential to the polynomial. So we have to trade off between space and time complexity from time to time. In the in previous time when the storage facility was not so good, so we have to stick to the less space complexity. But in the modern era, as the storage capacity is rapidly increasing and as well as the processing powers, we are going more towards uh, using the more optimum solution without thinking about space complexity as well as the time complexity. But still we have to uh, take it in our mind that we have to optimize both the things. Even if we talk about the databases which we use, here the main thing is space, the space in which we have to store our data, and the time to fetch, the time to take the data. So what we can do this, we can decrease the time, we can decrease the time complexity by installing a new memory, which can be cache. So what happens in the scenario is that we store the most frequently used and most frequently asked databases query in the cache. So it reduces the time, but the cache is very expensive and it is one of the resources of the computer which we are using. So it will increase the space complexity. So in the scenario of computer science, we have to do the trade-off between space complexity and time complexity from time to time.
So, how do you approach optimizing both in a real life scenario?
So, from my point of view, I would go first towards the time complexity. I will try to reduce the time complexity because it improves the user experience and it also reduces the lagging of the system on which we are working. So, if I'm solving a problem, I try to use the dynamic programming based approaches to reduce the time complexity, and I try to use the most optimum solution that I can to solve a logic. And this is how I face this situation.
Okay, that's great. So, moving on to the next question. How does a Bloom filter work? Have you heard about it?
So, sir, can you say it again?
Bloom filter.
Bloom filter.
Yes.
So, actually, I don't know about it.
Okay. So, let me tell you about this.
Okay, sir.
It is a device used to detect whether an element is present in the pass or not, that is, in an array or
Okay,
a
okay.
storage. And it is generally used whenever the data is very large, maybe in millions and trillions. So, this data, like millions and trillions, may increase the time complexity, as you know, a lot
Yes, sir.
if we
Yes.
try to solve in a polynomial time complexity too. So, for this, usually we use the Bloom filter, and the main concept of this is it consists of a filter with which generally gives two output. a false negative and a false positive.
False positive.
Yes, but in our case, specifically talking about Bloom filter, it only gives false positive. False positive, that is, the data might be present. It not assures that data would be present, and it generally do not allow false negatives. That is surely not present. It doesn't consider this, and you may go through this later on. The
Okay,
part
sir.
is how,
Definitely I will.
yes, that how exactly the Bloom filter work.
Okay, sir. Thank you.
Yes. So now moving to the a problem for which I would need you to share the screen.
Okay, sir. Is the screen visible?
Yes. Can you open your lead code account?
Okay, sir.
Okay. Search the problem number 93.
So this one, restore IP address.
Yes, yes. Okay, Pransul, you can go through this question and try to solve it within 10 minutes.
Okay, sir.
Yes. Pransul, you can see clock that is present in on your interface. At the center,
Yes, sir. Yes,
yeah,
yes.
please set the timer of 10 minutes. That would be better. Just start it.
Okay. So we have given a string in which we have to insert the dot to make it a valid IP address. And we have to return all the valid IP addresses that we can build from this string by inserting three dots in any position.
Okay.
So
What
I'll
would be your first approach after seeing this question?
actually I'm thinking to put the dot in the string by visiting all the paths, like applying dot after 2, applying dot after 5, or maybe applying dot in the last. So I'm trying to visit all the path, all the approach, all the solutions that I can have, and to visit all the path we can use the recursion. So that's why I will move on with recursion. That would be my approach.
Okay. Uh, okay, you may continue.
Okay, sir.
Hmm. Hmm.
So in this function, we will take three parameters. One is the current position or the index. One is the string we are building. One is the length of the current number which we are trying to build. And the length of the number cannot exceed 3 because uh, most highest length of a number can be only can be 3, which can be 255. And we can take the previous digit as num, and we can take the dot counter, which cannot exceed 3. And the base case of the recursion can be when index gets out of bound. So we will apply the base case here. So what we have to do is, as I can think that on a position, we have two probabilities. We have two things which we can do at any position. First, we can take that number into the number we are building, take that digit into the number we are building, or we can just put a dot there. So we have two things. First, to take the number, and first to uh, put the dot, and we have to build the array. So when can we take a number inside the string we are building? So we can do this when the length of the number is strictly lesser than 3. And first we have to take, I think we have to take the digit into the account, the current digit. So let's build the digit. So it's the number we are building, and so it will give us the number which we have built. For example, 255 can be read as 255 or 245. So we have to build the number like this. Num inside this variable, we have the number which we built on the previous function invocation, and we are building the number, that number again by including the current digit as well. So we have to check if the length is less than 3, the length of the number which we are building is less than 3, and the number is also less than or equal to 255. So only in this situation we can take the number. And we also need the most important edge case that I am seeing right now is to remove the condition of getting the leading zeros. And to counter this, we have to tackle this situation. If the length is 1, we will check the length is already 1, so we have to check that number is not 0 actually, the number we are trying to build. So in this situation we can apply this. So what we have to do is that we were building our array. It's a backtracking based approach, so we have to remove the number again so that we can move on to the new possibilities each time.
And what will be the complexity, time complexity, the solution you are going to perform?
The time complexity can be 2 to the power n, because we have two possibilities of 1 to put a dot or 1 to take the number into the string.
Okay.
So it can be 2 to the power n, but based on the constraint is only 20, from 1 to 20. So we can apply this time complexity because the constraints are very less.
Yes, yes. And what about the space complexity?
So space complexity, we are just using the array of O of n, which is O of n. So we are just using the array,
Okay.
which we will return as an output.
Okay.
So the space complexity is O of n. Here n is the number of solutions that we can create.
Okay. You may continue. You may take 10 more minutes.
Okay, so thank you.
Yes.
And if the length is not equal to 1, we can simply do this, because now we don't need it. We only have to check about this case when we are taking our second digit. We have to check that we don't take the number with leading zeros.
Okay.
Now if we come to put the dot, we have to check if length is greater than 0, which is obvious that we cannot put 2 dots consecutively. And we have to check that the count of dot is still lesser than 3, because we don't want to put more than 3 counts. So we can use it again. We are not moving to the next index, we are just putting the dot. So we will not move to the next index. and the length will become 0, the number will become the 0, and we will check it. Now let's come to the base condition. If the count is less than 3, because we want our counts to be exactly and precisely 3, the count of the dots. So if the count is lesser than 3, we will simply return it, and we will put the string into the answer and return it. So I think this should be the solution.
Okay. And what are the edge cases that you think would be in this problem?
So the biggest edge case that I discussed is the leading zeros. For example, in this, as you can see it here, here we have the leading zero, and which is not a valid IP address. So we have to tackle this.
Yes.
If the length of the number which we are building exceeds 1, we will check if the number we chose was 0. If it was 0, we will not take it. We will only take it if it was not 0.
Okay.
And another edge cases can be to not put 2 dots consecutively. So we will check if the length is greater than 0, the length of the number which we are taking, the length of the octets, the length of the number between 2 dots. So if the length of this number is greater than 0, only in that condition I will take the dot. And if the count of the dots is lesser than 3, so because we only want three dots in our IP address.
Okay.
And we also check in the base condition if the count of dot is not equal to 3, we will return it, because the count of dot x should be exactly 3. There should be exactly 3
Yes.
counts.
Yes.
So I think this should work. And
Okay.
we will,
Okay, Pransul, can you run this code?
okay, sir, I will try. So as you can see that this solution is working, and we are getting all the possible valid IP which we can restore from the given string. All the test cases are running properly, and I think
Okay. Can
if
you
you
perform some
allow,
of
I will
the
submit. Yes, sir.
Wait a minute. Can you perform the edge cases that we have talked earlier?
Okay, I will try to perform it. For example, we will give the test cases like 0, 0, 0, 0, 0, 0. So ideally, it will try to, it should not create any of the valid IP addresses,
Okay.
because there will be many leading zeros in this case. So if we run it, so the answer array should be empty. So as you can see, that answer array is empty because it will not create any of the array, any of the IP address without any leading zeros.
Okay. Okay, you can submit the code.
So it is running properly.
That's great. You were able to solve the question, and that's it for this interview. And I hope you have learned some good things from this.
Yes, sir.
And do you have some feedback for me? Or question you may ask?
So I would like to thanks that you first of all, you break the ice for me by making me comfortable with the interview, and you also try to teach me the things which I was not able to answer. So that's very kind of you, and thanks for teaching me. And I will teach. I will also learn them in future. So that's the feedback from my side.
Yes, yes. So coming to your feedback, I would say you were really good at the questions that I've asked, and few things you may keep in mind whenever you go to the next round might be that whenever you answer a question, try include the time complexity and space complexity with your solution.
Okay,
That
sir.
would give a good impact on the interviewer, and also the few questions that we have discussed, like the bucket sort,
Mm.
convex L problem,
A star problem, A star algorithm,
yes, A star problem, convex L problem, bucket sorts, and the
Luma filter.
Luma filter. You may go through these all problems that are really good problems, and that's all from my side.
Okay, sir.
And I hope you like the session.
Of
And
course, sir.
thank you.
Thank you, sir.